if you see that all your spikes are corresponding to the artifacts, you may want to use this clean interval variable to detect spikes without artifacts.
Yeah,
So,
I have one. Yeah,
and then you can use those variables instead of segment variables.
Yes, so I have a question here. I see there's many raster, many bins in the channels. So are they all the like all of them are spikes?
Yes, so all this each tick mark is a spike, so it's a timestamp. It's a timestamp for the spike.
Can we see the continuous signals in color? Like I don't know how to describe it. Yeah, in the continuous, like in 1D viewer, there's a signal.
Okay, so let's
in different colors.
Let's remove the old spikes. Just so we have this ones, and we can show, for example, continuous variables here if you want to look at them. This is all just visualization; it's not analysis. So these are just the timestamps, or you can remove some of the spikes and just look at the waveforms. You can add the waveform variables. For example, this couple. And then you have to kind of zoom in to one of the waveforms. So these are actually waveforms, you can see. This is the waveform. So this waveform corresponds to this SPK001 neuron timestamp.
What is the SPK001 waveform? That is the spike?
That's the spike, yes. That's the spike waveform.
Okay.
So you can, if you remove the other channel, so this spike waveform corresponds to this kind of area of the actual continuous signal.
Yeah. So if there's if there's noise like breathing noise, can you go back to some place that there has the breathing noise? Let's see what it would be in the waveform channel.
Okay. So if you go to, let's go to the noise. So breathing.
Yeah, here.
Here. So here, so these are the waveform, the spikes that we detected. So this kind of peaks. If we remove the other two, and we can get the waveforms from that were originally detected. Segment 001. You see the only
okay.
the waveform that came with the file was here in this artifact area. So now we have spikes outside the artifact areas.
Okay,
so
thank you.
Spike.
Thank you, Alex. That's clear enough. 安娜老师，您这边还有就是针对这一个问题还有什么疑问吗？他刚刚的解释，就是有没有解释的不清楚的地方？
我捋一遍啊，是他刚刚进行的，就是在时间轴上面通过创建那个自动甄别了那个噪声的那个时间区间，然后他就去掉了噪声所在的时间区间，然后对其他部位的时间段的信号进行了分析，然后重新识别出了这么多的 spike 信号。然后生成了这个 SPK001-WF 这个通道，是吗？
对，是的。
然后那个 WF-SEG001这个通道是我们
是之前的
最开始记录的时候，我们自己手动 segment 出来的 spike 是吧？
对，是的。
然后它那个叫什么？就是 它进行的这些 clean，然后这些操作是不会在 raw data，就是那个 SPK001上面，进行改动，它只会生成一个新的 channel，就是这种间断的光栅图，是吧？
对，它生成的新的 channel 叫，就后面有一个杠 NR 的那一个。
哦，好的，我
这个可能一下子可能会全部很难记住，但是如果回看它的这个视频的话，应该是可以按着这一个来操作的。
好的，中间我记得他演示的时候，他是不是在做那个 clean 的时候演示了3种方法？一种是手动的自己拖一个区间的方法，还有一个我记得是点那个 help，然后那个自动生成。
那个是一呢是手动点手动识别，一呢是噪声区域，然后第一个噪声，然后第二个噪声，然后它进行了一个反向选择，就是排除掉这2个噪声区域的其他所有区域，这是它的第一个概念。然后呢，它识别之后呢，它还应用了去自动计算它的面积。就是自动计算1和2 interval 的面积，就是噪声1和2的面积，然后呢，再应用了它的低频噪声，就是使用低通滤波，然后低通滤波完了之后，它滤掉了3和4赫兹的噪声之后，它还进行了一个操作，我也忘记了。然后它的这些操作其实就是为了得到一个 clean 的就是干净的信号，它所有这些操作背后的这些原理啊，我没有特别明白，但是大概知道它的操作，然后得到一个特别干净的信号。然后呢，他说这个干净的信号呢，就是步骤较多，所以他创建了一个Python script，然后这个 Python script 就是为了实现他所讲的这一些步骤，就在 help 里面，然后输入70，它就会运行，就不用再进行前面这么多复杂的操作。
所以他之前在那个就是我记得是在那个 edit 那个选项里边进行了操作，然后产生了几步那个比如说0赫兹以上啊，然后那个比较干净的一个波形，那些都是我们点 help 那里面进行的那个分析，它自动分析的原理是吗？就是它自动帮我们进行这些步骤。
对，这一部分是我所理解的，但是两步是否同步就是进行，还是说先就是两个是同样的目的，还是说是先后的顺序，这个我还可以再确认一下。但是大体上就是应该是就是替代前面的3个步骤，然后呢。它运行这个 Python script 就可以直接得到。
好的。那我没有什么问题了。
OK，
Hey Alex.
Yes.
Yeah, Alex, I have 2 questions. Just now, Ivy and our customer is discussing about 2 ways you showed us in removing the breathing artifact. First, you showed us how to manually set an interval and then remove the breathing artifact. And then, secondly, you showed in the help and into the script 70. So these 2 are actually, they are doing the same thing, but you did us a favor. You created a script to do all the manual steps automatically, right?
Yeah. Yes, exactly. Yes.
So
I can,
yes, please.
So if you have kind of a problem like this, you can always email me, and I can add another script if it's not too complicated. But this script, it took me like maybe 2 hours to experiment and write the script. But yeah, I'm open to this request. So if you need something that's a tedious work and that's kind of repetitive, you can reach me over email and we can discuss if this can be done by the script.
Thank you so much, Alex.
Thank you very much, Alex. And second question from my side is, the script you created for removing the breathing artifact. This is a little bit about algorithm questions. Like, can I use that for removing something else? Like when the animal is, I don't know, shaking, or like maybe heartbeat artifact, or maybe like 50 hertz artifact. Can that also be used on those?
So for it depends. So if you can clearly see that your signal has this, bumps in the amplitude. So if you can think that, yeah, this is the amplitude, so I can find the areas where the amplitude of the squared signal is too high, then of course you can use it. It just it has two parameters, the channel and the number of standard deviations from mean. So you can play with this second parameter, standard deviation, number of standard deviations, to make it kind of more inclusive of the noise or less inclusive. Of course, yes, you can do this, sure. And this is now if you want to actually to look at the script itself, you can actually modify the script if you know Python and do something else. But for now, it's for those who do not want to learn programming, it's a menu item.
Thank you, Alex.
Okay, Alex.
One more question. Sorry, Ricky. One more question. Just now, like Ricky mentioned, 50 hertz noise. I think this script cannot be used in 50 hertz noise, right? Because it is continuous.
Yes, it's continuous, and yeah, so it's not like it doesn't show itself as a high amplitude periods.
Yeah.
Let me show you how to do this. So let's do this one. So we want to open. So I have data file, and so I just open my test data file that comes with the program. And if we analyze continuous channels, let's do, for example, continuous data, power spectra for continuous.
Sorry, Alex, this step is to remove 50 hertz, right?
Yes, so I'll just show you.
Okay.
So I have the data that has lots of frequencies. So this is 50 hertz. So no, this is it's 30 hertz, 60, etc. So we have this. I just shown you the example. So let's look at the power spectral density. So this particular variable has really heavily contaminated, for example, with this 180 hertz noise, right? So if we want to, I'll just show you how to remove this peak, for example. So to do this, you go to, again, edit, menu, digital filter, and in the frequency response, you select the last one, notch. Notch filter is basically will cut the frequency that you don't want. So if you have 50 hertz, then you specify 50 here, but now we will do like 180 hertz, and the variable will be like, I don't know, filtered. Okay. So now we go to continuous variables, add filters for analysis. So you compare. So this is original variable. This is the one after we applied the notch filter for 180. So we don't have this peak. So that's how you get rid of 50 hertz.
Okay, so to get rid of 50 hertz, we need to open the data and choose the analyze power spectrum for continuous, and then we choose.
No, you don't have to. No, you don't have to analyze. If you want, this is just for visualization. This analysis is not used in the cleaning. So if you want to clean 50 hertz, you go to edit, digital filter, and select the last filter, notch.
Okay.
And specify 50 here, 50 hertz. And then the name of the variable. So this works for one channel only, but it could be all automated with a little scripting. So this is how you do this for a single channel.
Mm-hmm.
Okay. Okay, then we had questions about firing rates and
Sorry, Alex. Then how can we do to clean the 50 Hz in all channels?
in all channels you would have to use a script, like with a few lines of script. I can write it for you. So that's but
Yeah, thank you.
The main idea is that I can show you a little bit of how this works. Let me share the whole screen. So you go to script, and for example, I have this script to apply interval filter to all variables. So this is the whole script, and you get the document, you get the names of the continuous variables, and then for each SPK variable, you apply interval filter. So the same idea will be here. So instead of interval filter, you will have like notch filter.
Yeah.
So that's the whole kind of procedure of doing this for all the channels. So if you need this, I can make this script for you, and then just to make sure that you understand how to run scripts, you will go again to download support files, then script, open the script that I just sent you, and then here you select script, start, and it will create all this, all these variables with clean before the name. So the idea is that you take the name and you generate a new name for the new channel with the prefix clean plus name, and then you do something with your original channel. That's the idea of the scripts.
Thank you.
罗
老师这边还有什么疑问吗？
没有。
Okay, yeah, please move on. Thank you.
一个小小的问题。
Yeah.
50赫兹的这个操作是只在连续信号里面需要用，对 Spike 是没有用的，是吧？
没有，它只会去除像50赫兹，像刚刚演示的180赫兹这样子，它不会把那个 spike 给去掉，因为这是50赫兹，如果出现50赫兹，它一定是连续的。如果把所有信号都去掉的话，那所有信号都没了。
好的。
Okay, yeah. Alex, please. Thank you.
Okay, so you wanted to discuss firing rates. So what do you need with the firing rates?
Firing rate is that like we have spikes in the in data, and customer would like to know what is the firing rate in each channel.
Okay.
Spike firing rate.
Okay, there is a special analysis called firing rates analysis. So here you have to specify time intervals where you want to calculate your firing rates. Since your data that comes from alpha omega systems don't start with 0, so you have to kind of look at the actual interval. To do this, I would usually go to intervals and all file. So all file interval shows you the start, like 6670, and the end 6870. So now let's do the firing rate analysis. So it's 6670, 670, 6870.
安娜老师，因为我们的数据它不是从0秒开始的。
70. Okay, selected variables. Okay, go. So it shows you numerical. So the main kind of results you want are numerical results. So go to view, numerical results, and this shows you the firing rate of each of those channels. So for the original ones, it's very low, and now with the NR, they are much higher. So we have like one spike per second. So this is how you get the firing rates.
Yeah. 安娜老师有什么疑问吗？这个步骤？
那 firing rate 的定义是1分钟，
就是放电频率，对，每分钟放电的频率，每秒放电的频率，
就是次数，就是1秒钟放spike 的次数除以
对对对，
那个秒数。
1除以那个放电的次数。
1除以放电次数，不是吧？
不是，是那是每秒放电的次数。就像50赫兹的噪声，它是1秒钟，对，50。
好的。
就是你会在那个之后，就是在你会在之后比如说论文。就是在你的数据里面，你会看它大概放电频率是否有变化。譬如说，后续如果加入比如说体温就是什么温度刺激啊，或者是电刺激啊，它的放电频率是否有变化，这是其中的一个你可能会用到的地方，观察它的那个放电频率是否有变化。或者是光刺激啊等等之类的。就是您可能现在没有用不过没有关系，这个您可以大概了解一下这个。
它现在的柱状图是2根是什么意思啊？
一个是等一下啊，它应该是一个是 NR001。Alex, what is 1 and 2 for? 1 and 2 channel?
This is no, this is interval. So this analysis is made for people. For example, you have long experiment and you have before something like, for example, psychology. Some people working with like they apply some drug, then they want to see the firing rates before drug application and after drug application.
Okay.
So you can specify the intervals before
I see.
I
see. Thank you. 就是比如说他说用药之前用药之后，他这个可以选择在所选时间段之内或者之外的一个对比。
好的。
Okay, Alex.
Okay.
Yeah.
So the next one was spectrum analysis. What do we need to do anything with spectrum, or we already looked at it?
Yeah, maybe you can show it again.
Okay. So let's just select some of the spike channels. And then we go to analysis of continuous data. Then we go to power spectra. And so basically you can use so the number of so the way the spectrum is calculated is that there is a sliding window of kind of a number of points that you kind of calculate the spectrum, not spectrum, like Fourier transform, so-called Fourier transform for each window. It's called periodogram kind of estimation of spectrum. So the more this value kind of defines how many values in the spectrum will be. So let's do with something simple like 128 and see what happens. So you see you have very kind of wide bins for the frequency. So if you want a high resolution in frequency, you want more values in the first parameter, number of frequency values. So now you have this spectrum value for very a lot of frequency values, and this is like and the last one usually you want to concentrate on some area, some frequency range. So let's go to like, now it's 500, let's go to 2000. So this is your SPK kind of channels and their spectra. Also, let's go back to the first, say, for example, first 200. And here you can also specify like a old file or clean. So clean and go back. So it's, and by the way, let me show you one trick that's kind of difficult to understand. So not difficult, but hard to, for example, if you want to compare your spectra for two sets of intervals, you can go to data selection, say multiple filters, filter table, and then let's compare old file with clean. So you want first to calculate spectra for all the file, and then only for the clean intervals of the file. So this is old file, this is clean. But now we can also graph overlay option. Press here, graph overlay options, overlay graphs. Okay. So now we have two spectra for each variable. One is for all the file, and another is for only from the clean intervals. So this is how you can compare analysis results from different time periods of your data.
OK， thank you， 秋萍，陈老师，这个像 Pulse Spectrum 一般就是上次跟罗老师讨论之后，这个是比如说能量频谱图，它主要用在哪方面较多呢？
喂，艾薇。我觉得能量频谱图就是我们特别是手术过程当中用来判断它某一个频率的这个放电比较多，这就是手术靶点判断用的比较多。但是在这边我不知道他们是
就是比如说某个位置的放电频率，它可以某个位置它的就是不同靶区它的放电频率不一样，对吧？
对。
其实那个在科研领域，这种能量频谱图是用的非常广泛的。你比如说结合某些行为，或者是给某些刺激。那么在做某个行为的过程中呢，它可能会观察这个里面的放电，因为本身电生理呢是一种相对来说最基础的手段，单独的它呢可能就没有意义，它必须跟其他东西结合起来。你比如说我给电刺激，或者是给一些视觉刺激，或者是给一些痛觉的刺激，对吧？就像你前2天在那个空军大做的时候，徐老师为什么要摸摸他的脚，看看他那个看他的那个坐骨神经或者背根神经那一块为什么会放电频率比较高呢？那这时候呢，其实你如果要看的话，就可以看他的能量频谱图，可能会是另外一种观察的形式，而不只是我们去肉眼去看他的那个地上的那种burst的放电，对吧？所以就是它的应用是非常非常多的就是当然那个刚才视频说的我们在临床领域这个用，那就是在术中，你比如说做 DBS 它看那个运动区域它那个地方，因为它有帕金森病了，所以在帕金森病呢，它有可能会就有那种50到60赫兹的这种那个放电，那它这个时候呢，看看这个50到60赫兹的这种放电，还有它的 spike 是不是在这个区域特别集中。它有可能会用能量频谱图，所以应用非常非常的广泛的。
好的，像它在纵轴，它是用的分贝这一个，是 dB， 它这个单位，就是像纵轴，它主要是能量的单位，是吧？
它实际上它那个单位没有一个直接的单位，它就是一个数字，比如说1、2，它有个相对值嘛，那个能量频谱它本身是有一个基线，有个相对值的。你比如说他们常用的那个均方根，对吧？那么均方根呢，它就是把它平均以后，然后呢， 相对于这个平均值，它不是简单的我们1加2加3然后除以3这样的平均，它是用平方根。当然也有很多种算法，就是在那个数学上有很多的解决问题的办法。然后它相对值相对值你可以把它理解成是一个倍数或者死刑的，但是我相信每一种算法呢都有代表着就是一定的意义的。
好的好的。谢谢志峰，谢谢陈老师。那个安娜老师，这一块您有没有什么疑问呢？
暂时没有。
好的。如果后面还有什么疑问，也可以继续再讨论。Alex?
Yes.
Sorry. Yes, please move on.
So once again, what did you say?
Yeah.
Okay. So
yeah. We are fine.
Variant histograms. So here, variant histograms, we can actually do this for our
sorry.
Yes.
Sorry, Alex. I think we should go with raster first.
Okay. So let's remove everything. Select a few channels. So do you want rasters for spikes, right?
Yes.
So we go to rasters analysis. You just here you have to specify minimum, maximum, and that's it. So it's just the time value, time axis parameters. That's it. There's nothing. 76, 70. Okay. Post-analysis. Okay, so we have to post-processing script. Let's remove it. So this is the rasters analysis. So you see, you just have the ticks for the channels, and the way actually I did a little bit of changing of the standard analysis options. For example, so this is for a customer who wanted to see so-called network spikes. So there is a script that would draw like rectangles with the spikes that happen on many channels. If you see something weird that doesn't look normal, you double click and then press restore defaults. So it will restore defaults for this analysis. So if you go back, now we have to specify 6670, 6770. So this is your default raster analysis. So
yes, this is default one. Why are we like operate? Why are we choosing other options in your first step?
So other options because the customer wanted to show the kind of the rasters one in one column. So
I see.
one above another. So to do this, we need to look. We can do this in properties and graphics properties. Number of columns. Now it's automatic. We can change it to none and apply. So now we have all of them kind of one under another. So that's the idea.
Okay, thank you.
Okay.
安娜老师，这一步有什么疑问吗 ？raster 这一块操作，
这个操作是不是也是就做这个 raster 这个分析，是不是也是要先做那个去除呼吸噪声那些步骤，就是处理完的数据才可以用来做。
是的。
网站图。
它就是每一次，它每一个其实跟之前的那个 firing rate 您就是看到那一条数其实是一样的。它每一个放电，它就会有一个数，就是有一个数线在上面。
那它这个就是光圈图，它会帮就是除了看到这样的图的形式，它会有那种比如说 Excel 表之类的，它会帮统计，比如说 第一个 spike 和第二个 spike 之间的那个间隔时间啊，
间隔啊，
对，因为它不是公式，有的隔得近，有的隔得远嘛，它会把这个间隔多远的这个数值统计出来嘛。
首先第一个是 Excel 表格，我应该是有的，一会我问一下哈，这个应该可以导出 Excel 表格。第二个是除了 Excel 表格之外，能不能自动生成它的放电之间的间隔？我问一下Alex，
Yes.
can we export first? Can we export this file to Excel format? And second, can we calculate? Can this software automatically calculate the interval between the last rasters?
So for the Excel, if you go to the data window, there is timestamp tab. So these are all the actual values of the timestamps.
I think this value is for before we remove the breathing noise, right?
Yes. So you can you can go like this. You can go to, so this is our new with NR. You can select columns, right click, copy, and then go to Excel and paste. Inside Excel.
Okay. And can we calculate like this system this software can it calculate the interval between the rasters, right?
So
can we have this
like from first and last within
this? Yeah.
Not currently. So you may kind of do this again in a short script, but it's not anywhere that's available as a menu. So
okay. 安娜老师这边就是 Excel 表格，他刚刚也有演示哦。他那个如果后面去就是比如说 harassment 之间的间隔的话，可能就是得要一个 script 吧。
But yeah, I can write a simple script, so it's not. This is very simple. So you want to calculate what, like for example, within this so this time minus this time.
I think customer do not have exact requirement for this one. So roughly she might know that she want the interval, but she do not know how detailed. So maybe afterwards, when she has a detailed requirement, I will send you email, or she will send you email.
Okay, sure. Okay.
Thank you. Yeah. 那个安娜老师这边还有其他疑问吗？
暂时没有。
好的。OK， 我们还有一个 PSTH 的，这个比较接近，我看一下是不是最后一块。对，就是还有最后一个内容，可能估计也要10分钟左右吧。我们有点延迟了啊。Alex, we have the last function PSTH. Sorry for yeah.
Okay, so it's per event histograms. So you select the neurons, then you go to per event histograms, and here you can specify a reference. So which will be your stimulus if you have a stimulus, but you can also specify a spike train. So let's take the first spike train and use it as a reference, and then you say how. So then you kind of, this analysis calculates relative spikes, so bin counts for the spikes that happened before and after relative to the spike in this SPK 001 NR. So we say we want 200 milliseconds before, 200 milliseconds after, and each bin is 5 milliseconds. And then you go to data selection, use all the data. Here we just say, let's go to the interval filter none, don't do anything. And then we just click OK. And this is what we have. So we have, for example, what this Pirevent histogram shows. It shows that there are a lot of spikes in SPK002 that are almost synchronous with the spikes of the reference channel, or it would be your simulation. So that's the idea. And then you go again to numerical results if you want numbers. And in the summary, you can see the confidence, all kinds of background. You can find the peak position. So for example, look here, we have zero beans before peak position. So it says that for 003, peak position is 2.5 milliseconds. So that's position of this peak. So that's the analysis. If you want, actually, Pirevent rasters will also give you some similar information, but with more details. Like if we go back to specifying this one as the reference, and then file order, so type none, okay. This is not okay. So we need to change the graphics.
好的。
Thickness points on. So now you can see that with the 003, there are lots of spikes synchronous to channel 1, and then some of them are before and after. So this is Pirevent raster. Slightly more it's kind of different information than Pirevent histograms.
Alex, what is the zero? Zero means some.
Zero means that I can send you to a web page that explains what is Pirevent histogram. So zero means that there was a spike at SPK001 at 0, and then for each spike, so we need to go back to the rasters, but for each spike in 001, we kind of look. I'll have to send you. That's the explanation. Let's just do a search. I'll just do a search. Just a second. Pirevent histogram. Okay. No, that's there was one in UPenn. Let me see if I can find UPenn. Yes, joint peristimulus time histogram. No, that's joint. Okay, UPenn.
Perry stimulation time histogram is PSTH, and that is what we require for.
Yes. Cross correlation section. Okay, so this is. Let me show you the site that explains this. It's a site from UPenn. Can you see it? So it's the same as Pirevent histogram. So you have a target. That's our channel 1. No, you have reference. So we kind of align. So we look at the reference spike, and then we look at another channel, for example, channel 2, before and after this spike. And if there is a spike, we add +1. So if there are a lot of spikes that are kind of immediately following the reference, then we'll have a huge peak here. So that's the idea. Then we go to the next spike and do the same. We kind of shift this kind of grid from one spike to another. I can send this to this link to this page. So that's
Okay.
cross correlation. This is the same experiment histogram. Okay, so where is it? Where is the? I can't find
the chat.
Oh, here the chat. Okay, the chat. So this is the explanation. That's the best explanation there is. Okay. Okay, so let me go back to stop sharing and share Neuro Explorer. So this is what it shows you. So
if we want to know what is the firing differences between before and after stimulation, that is the idea of the PSTH. What should we set as 0? The stimulus?
Yes, it's called reference.
Yeah.
So reference.
So how can we?
So here, but in the parameters, the first parameter is reference. So you just say, so if you have it shows you a list of all the events and neurons. So if you have an event, then you can use it as a reference. Stimulation event. So this is where you specify what is the reference, around what timestamps you want to look at your firing rates before and after. Since I don't have stimulus, I'm just using spikes, which is the same as cross-correlogram. And this is rasters, and the same thing goes to per-event histograms. So we can go to this channel with the largest number of spikes. So always change the reference. So your reference should be your stimulation event.
Yeah.
Here.
Okay, thank you. And 安娜老师还有Vicky 陈老师这边有没有什么疑问？
我没什么疑问。那个龙老师这边有没有什么问题也可以提出来的？
By event, I mean timestamps. Timestamps when you did the stimulation.
Yeah. 安娜老师这边还有什么疑问吗？
那个图里边的那个纵坐标，它的那个注释是 count 除比上 bin， 那个 bin 的是什么意思呀？bin 就这个是什么的？
之前理解我以为是放电的那个。陈老师，这个你清楚吗？bin是什么东西？Alex, what is bin mean?
Bin is the bin. Let me show this picture again.
Like I saw the counts is equal to bin.
Yeah, so bin is the width of this window. So we look at the reference event. It could be a short bin or a long bin. So we count how many spikes in another channel will be within this window. So this could be narrow. So now we have 5 milliseconds. But we can set it to, for example, 10, and then it will be just kind of not as detailed information. But then we will count these spikes within a wider bins.
So we can set the interval, like the duration for the bin, right?
Yes, the bin size. Yeah. So here, let's go back to the one that we used before, and here, so that's the bin of 5 milliseconds. We can set it.
Okay.
So this is where we set the bin. So the bigger the bin, the 20. So now you have kind of all the spikes that are within from 0 to 20 milliseconds after stimulus will be in this column. Or if you want just 1 millisecond bin, then you'll have the kind of ugly picture. Usually you want something a little bigger than 1. Depends on how many spikes. If you have lots of spikes, you will have some kind of nice curve showing you. But the main kind of information we see right now from this particular result is that if we take spikes on channel 1, then spikes on channel 2 and 3, for example, and 4, so all of them have lots of synchronous spikes, except for channel 6. So channel 6 doesn't have any relationship, so it's kind of random relative to spikes in channel 1.
I see. Thank you.
The same will be, so if it was a stimulation, we will say that channel 6 has no reaction on stimulation, and all other channels have. So that's the idea.
Great, thanks.
安娜老师还有什么疑问吗？龙老师这边？我这边没有。好的，这个可能是暂时因为上次的数据也没有用到刺激之类的，所以这一块可能目前这一个数据暂时没有用到，不用用到这个功能。后面如果有需要，也可以再来回看这一次的视频。好的。罗磊老师这边有什么疑问吗？
我这边好像声音听不见。
听不见吗？不好意思是一直都没有听到吗？
我能听得到，你们能听见我说话是吧？
可以，现在可以的。
刚才我有提问，然后就是听不见。好，黄老师，那个
实在抱歉
没事。OK， 这个 Alex 老师讲的非常的明白，然后因为我吧确实是不太这些参数，然后我知道什么意思，但是这个细节我可能因为有这个就是录像，你们回头麻烦我不知道能不能跟我们共享一下。
可以分享的，肯定的。
对。然后非常感谢这个几位老师，还有李琦，然后还有刚才的李总，然后王老师，谢谢你们，非常感谢。这个讲得很清楚，然后我们有不懂的，可能要自己摸索，就是光靠 Alex 老师去指导就也不是个事儿。对，但是让我们入门，我们挺高兴的，非常感谢。
没有，这是应该做的，不用客气。有什么问题的话，也可以随时联系我，或者是李琦。安娜老师在后续实际操作的时候，就是如果有什么疑问，我这个回放的话，可能今天晚点，或者是因为一会儿我可能就赶飞机去了，可能今天不一定能发出来，或者明天我会发出来给到各位老师。谢谢大家。然后是龙老师这边可能好像也没有听到。那我们的可能培训就因为暂定的内容是这么多，是根据安娜老师之前的提问来制定的这个培训的具体是培训讲解哪几个功能。就是后面如果有什么疑问，我们再回放视频或者交流。各位老师还有其他更多的疑问吗？如果没有的话，我们可能今天的讲解就到这里。
没有。
好，谢谢各位老师抽空，感谢。Thank you, Alex. Our customer is very happy with your explanation on the detail operation of all the functions. Thank you so much.
You're welcome.
It's wonderful, great. Training for us. It helps us a lot. Thank you so much.
You're welcome.
Thank you.
Thank you, Alex. Thank you, everyone.
Okay, great. Thank you, guys.
Eric, you are mute.
Hi, Eric.
Eric, you are mute. We cannot hear you. I think he has some problem with the earphone,
maybe
or
internet.
micro. Yeah.
Yeah, we are glad to have you. So in the future, if we need more, we have more requirement for the script, we will send email to you, and Anna, my director, will send email to you also. Can you please share your email address here?
Oh, sure.
So
yes.
that in the chat. Okay. Okay. Great.
Okay.
Great. Thank you. Thank you.
Okay, you're welcome.
Thank you so much. 拜拜，
Okay.
各位老师再见，
Bye bye.
谢谢大家。
Thank you, Alex.
Bye.
Bye.
Have a good night, Alex.
Thanks.
Good night. Yeah.
Okay. Thank you.
Have dinner as soon as
Thank you.
possible. I hope you are too hungry.
No.
I'm worried.
Yes. Time for dinner. Time for dinner.
Time for dinner, and your
Yeah.
grandchildren are waiting for you. Well, and don't forget to visit China in the future.
Okay, sure.
China is open right now, and we hope to see you soon for
Okay.
your first China trip.
Okay, sounds good. Thank you.
Okay,
Bye.
great. Thank you. Bye bye.
Bye.
Bye bye.